Leontief input output analysis. First of all, according to this theory, total production is equal to total demand, and this demand should be divided into two parts. One is internal consumption demand and another is external demand, which should be given externally. According to this theory, there were two industry produce outputs. This represent through matrix method. X11, X21, X12, X22, some external demand, total output. External demand is represented by D1, D2, and total output is X1, X2. In open economy, external demand should be always positive, but in closed economy, external demand should be zero. This term represent the output of first industry used by first industry in order to produce total output of first industry X1. Output of second industry used by first industry in order to produce total output. Output of first industry used by second industry in order to produce total output of second industry. Output of second industry used by second industry in order to produce total output of second industry. The row should be represent the output of respective industry and column should be represent consumption of respective industry. In order to produce X1 total output, we need X11 output. In order to produce one output, it should be divided by X1. In order to produce total output of X1 industry, we need output of second industry used by first industry. In order to produce one output, we divided by X21 by X1 industry. Technology matrix is denoted by Aij is equal to Xij divided by Xj. The term Aij represent in order to produce 1 unit of output, how much input is required, and Xij represented the output of ith industry used or consumed by jth industry in order to produce total output. The column represent X11, X12, X21, X22. Internal demand should be D1, D2, total output X1, X2. When we horizontally added X one plus X12 plus D1 is equal to output of first industry, and X21 plus X22 plus D2 is equal to total output of second industry. We also in take out to each unit output, we should be divided X11 by X1, which is denoted by A11 plus X12 divided by X1, which is denoted by A12 and X21 divided by X2 denoted by A21, and X22 is divided by x2, which is A22. So we write as x11 is equal to A11 into x1, x21 is equal to A21 into x2, x12 is equal to A12 into x1, and x22 is equal to A22 into x2. From this we get our technology matrix x1, two, A11, A12, A21, A22, D1, D2 is equal to total output of x1 and x2. This is coefficient matrix denoted by A. This is external matrix and it is total output. So according to technology matrix, I into A x is equal to I into A x is equal to D matrix to D matrix and A11, A12, 1 minute. So when this is identity matrix should be I into A into A inverse is equal to identity matrix both side multiplied by A into A inverse it should be I plus AX is equal to D. The Hawking-Simon condition is a feasibility condition that confirms non-negative output vector and solve relation of equilibrium in input output matrix where demand is equal to supply. There are two assumptions of Hawking-Simon condition. The determinant of I minus A matrix must be positive and diagonal elements must be positive. So A11, A21, A12, A22 is equal to 1 minus A11 1 minus A22 this should be because the assumptions of Hawking-Simon condition is diagonal elements must be positive and the determinant of I minus A matrix should be positive. So when when we subtract A11 from 1, it should be positive, and when A22 is subtracted by 1, it should be positive. So the condition should be satisfied and the Hawking-Simon condition should be applied.